Hey everyone, so I just want to make a quick guide on getting started with homework 2. Homework 2 is actually going to be completely with circuit.sim. The first file we want you to do is gates.sim, and the first gate we want you to do is a NOT gate. So remember, all gates use transistors. Get some transistors out on our canvas. And our NOT gate is, our goal is, when our input is 0, we want this output to be a 1. When we want input is 1, we're going to want the output to be 0. So in other words, when our input is 1, we want ground to step in, and we want power to shut up. And when our input is 0, we want power to step in, and want ground to shut up. And these transistors are going to help us control who's stepping in, who's being quiet. Alright. So notice, if you remember, ground is always going to be connected to an N-type transistor. Let's just play around and let's connect our ground to our N-type transistor. And notice right now ground is being blocked. Right. So let's connect our input to this gate signal. Now we can control whenever ground steps in or not. Right. We already got half of it done actually. So when our input is 1, ground's stepping in. So that's already half our problem done, just naturally. Now let's do the other half. So now when our input is 0, we want power to be stepping in. Right? So remember, power is connected to the P-type transistor. Let's just see what happens if we connect our input now to the gate. And look, this other half is done. So notice ground is shutting up. Power is stepping in when our input is 0. If we turn input to 1, ground is stepping in, power shutting up. Notice it's being blocked here, right? This green signal isn't passing through transistor, it's blue. So if we just connect them together now, we already have our NOT gate, right? And this is really harmonious because it's inverted behavior of our transistors, right? Notice our P-type is actually letting our source through, while our ground is not, because they have inverted behavior with respect to this gate signal. And we denote inverted behavior by using bubbles in our circuit diagrams. That might be an easy way to remember it. There's a bubble right before this gate signal. Alright, so what about when there's 2 inputs now? Well, it's kind of the same strategy where we're trying to figure out when ground should be stepping in and when power should be stepping in. Alright, so let's do a truth table. This stuff, I'm going to make it easier for us. This is A, this is B, this is out. So, for all the cases, so our NAND gate would look something like this. Everything would be 1, except for when both of them are on, and then it should be 0. So in other words, when both A and B are on, ground should be stepping in. And any other case, power should be stepping in. Alright, so we need to use transistors to control when they're stepping in. Alright, now I'm going to be doing the ground case for you. And I'm going to line these transistors up in something called in series. Oh, make sure these are N-types because we're connected to ground. And that's actually it. So notice that we kind of have 2 gates that this ground needs to pass through before it can reach out. Right? So only when both these gates allow it to will ground reach out. Any other time, ground will be blocked by one of the gates. Right? So this is called in series. Now you guys have to make power step in. So every time this wire is blue, power should be stepping in. I can't just connect power to blue though, because there'll be a short circuit. Remember, only one of them should be stepping in at a time. So your guys' job is to use transistors to control when power is stepping in. So for your NOR gate, I would follow that same approach of making a truth table and figuring out when ground should be stepping in and when power should be stepping in. All right. Now for these other two gates, instead of actually doing it from scratch, you can actually click on the circuits tab. So click on this arrow here, click on circuits tabs, and you can use your implementations of like NOT, NAND, and NOR and chain them together to maybe make these other two gates. Just an approach.